welcome back everyone. This is BW Audio Programming. Hopefully you saw my first video, but what we're going to be doing is finishing up this FM synth right here. So I already made a first video on this, and in that we basically dealt with creating that FM synthesis parameters, but then today we're going to be adding stuff like the ADSR, the filter, pitch wheel, and the stereo effect, as well as making everything polyphonic. So I'll have a link up over here so you can check that out in case you missed it. But anyways, yeah, let's get back into it. So this is where we left off last time. You can see over here we have all of the FM parameters, and then we have a simple MIDI keyboard control as well. So the next thing I want to do is let's go ahead and add just a simple ADSR to this. So there's an object we can use for that called ADSR tilde. Perfect, does exactly what we need. Has controls for attack, decay, sustain, and release, which if you didn't know, that's what ADSR stands for. And that's going to create our envelope that we can use to control the amplitude of the output here. So first thing we need to do is just create dials for all of these so we can control it. So grab a live.dial. All of these are just going to be time-based variables, so I'm just going to grab the time prototype. Make 3 of those, but then our sustain value, that one we actually want to be in amount. So there's that. I'm just going to rename these real quick. So we're going to plug these into these last 4 inlets here. First one is attack. Second one is decay. The fourth one is going to be release, but then for sustain, we actually don't want to grab the first inlet. We want to get the raw value because we want that to be a value in between 0 and 1, and this left outlet gives us 0 to 100. So if you do plug that one in, it's going to be loud when you actually try and implement it. So that's what we're going to want to do there, and that is going to create a signal in the ramp values that we've specified here. So what we do with that is, in order to control the amplitude of our output wave, we simply just need to grab a multiply tilde object, go to our output, let me delete these, and we're going to multiply the output of the ADSR with that. So that's how that's going to work, but then to trigger the ADSR, we need to send it our MIDI on and off note values. So if we go up to our MIDI parse object where we're getting our MIDI information, if you remember, this left inlet or this right inlet is going to be the velocity value for that. So we're going to need that, and let me play a few notes here. You can see that that gives us the velocity values when we hold it down, and also the note off value 0 when we unclick that. So we should just be able to plug that into our ADSR, and that should trigger something. Perfect. If you can see on this, where I'm hovering over the cable right now, you can see the actual signal, and that's working as it should. However, we are getting a large value of 52, and that should just be 1. Okay, so right now we're getting too large of a value because we're actually getting the MIDI. Here, let me turn this down. This is actually giving us values between 0 and 127 as the velocity, but we want this to be in range 0 to 1. So I'm just going to divide that by 127. Oops, that shouldn't be there. And let's see, this should give us a better range. Cool, it looks better. Yes, there we go. So we're still going to have velocity control of it. You just need to divide it by that so you don't go over 1 for your signal. So let's see how that sounds. Perfect. But the only problem we have now is, as you can hear, I can only play 1 note at a time. So I'm holding a note down right now, and if I play another, you can hear I don't get multiple notes, it just skips to the next note. And that's because we only have 1 channel of audio going at the moment. And every time we change the frequency with a new MIDI note, it just overrides the last one. So, to fix that, what we're going to do is change everything to an MC object, and we're going to have to do note allocation. But before I do that, I just want to implement the filter that we're going to use because that's going to be pretty quick and easy. So We're going to want to do this before the ADSR, and the object we're going to use is called SVF tilde, and that stands for state variable filter. And this basically gives you the option of you throw your audio input in the first inlet, and then these 4 outputs stand for different typical filter types. So here we have low pass, this is high pass, band pass, and notch output. And if you remember from the beginning, those were the 4 options I had in the initial example. So what we need to do is select between those. So I'm going to grab a selector tilde. Now we're going to have 4 inputs to select from, so I'm going to type 4. And remember, the first inlet is going to be the index to select which one we want, so we're just going to plug these in like this. Now I'm going to grab another radio group object like that. Now we need to rename this so we get all the values we want. Type in low pass, high pass, band pass, and notch. So there we go. There's that. We're going to add 1 to this because selector starts at 1. Actually, you can throw 0 into it as well, but that just turns it off. So that's a built-in functionality. But there's how that's going to go. Throw that into there, and then we just need to add our controls for the filter. So the second inlet is the cutoff frequency, and this last one is going to be the resonance. So let's grab another frequency dial. That one already works for what we need, in range 0 to 10,000. And then for the resonance dial, I'm going to grab an amount dial. So let me rename that to resonance. And then I'm just going to also get rid of the percent because I like resonance to just be 0 to 1. But that's 0 to 100, so let me change the range. Perfect. So now we can plug that into there, and let's see, if I turn this down, start playing some notes, and turn this up, we get nothing. That's because I need to initialize that. There we go. So there we go. Now we have a filter. Right now it's on low pass. If I turn up the resonance, you can hear that working. And let me just test out these other types as well. High pass, band pass, and notch. And you can actually see how that affects the signal down here in our spectroscope. But cool. That's pretty much it for the filter. And now it's time to get to the tricky part. Before I do that, though, I'm just going to clean this up a little bit so we can kind of visually understand what's going on a little bit better. So I'm going to be right back. Alright, so I just cleaned everything up a little bit. As you can see, up here we have the MIDI control, frequency being sent into the carrier. Over here we have all our FM parameters that heads into the filter right here. We have those parameters there. And then lastly, we multiply it by the ADSR, and that goes out. And then one thing I'll show you real quick is I replaced this long cable with a send and receive object. So in Max, instead of drawing cables, you can clean things up by using what's called send and receive. So if you type in send like this and give it a name, we'll say test. And we grab a receive, call that test. Then anything that's sent into the send portion for that will be sent out of its pair. So if I do that, boom, you can do that. And that's really useful once you start building larger patches and you need cables to kind of go across each other. It just really helps clean everything up. But you can also do a shorthand, and instead of typing out send and receive, you just type in S and R. And that is the exact same thing. So 2. Just like that. So that's what I did for this gate here. That's why you see send gate and R gate. So now the next part is going to be dealing with polyphony. So as you remember from earlier, right now we can only play a single note at a time. And every time we play a new note, it just gets overridden or the last note gets overridden. So we need to fix that. And the way we do that is with an object called noteallocator. mc.noteallocator. And it has to be MC, and you'll see why in just a second. Because what this is going to do is it's going to receive our MIDI messages, and for each new voice that has not been terminated yet, meaning if you're holding it down, you click a new one, it is going to allocate that voice to a new channel. And so we're going to eventually need to change everything into MC objects so we can have multiple channels, but that's going to be in just a second. So first I just want to show you what's going on with this. So first thing I want to do is grab a MIDI format, because this actually receives the raw MIDI messages. So if we take our output from our MIDI keyboard and the K slider right here, first I'm just going to pack these together so we get that raw message again. That is going to go into a MIDI format, so it's formatted correctly, and the output of that is going to look like this. Oh, I'm sorry, we need to get the right inlet from that because we need the MIDI event messages. So this is what it's going to look like, and that gives you the raw MIDI value for that. So we're going to take that. That is going to be sent into mc.noteallocator. And then what we need to do is we got to combine that with what's called MC target. So basically what noteallocator does is you send it a MIDI note message, and it has a few different outlets, but we're concerned about this last one here, which is called voice number. And for now, this first one, which gives us the note on pitch and velocity. So here, I'm going to play one note right now. So, first, we have to set the voices that we want. So we're going to want 10 voices for this. That way we can play a max of 10 notes at a time. And then I'm also going to turn on steal. And what that's going to mean is once you play more than the voices that are allocated, so if we play 11 notes and we're holding down 11, instead of just ignoring that new note that we pressed, it will delete the last note that was played and replace it with the new note. So we're going to turn that on, and let me show you now. So I'm going to play C here. You can see we get a value of 10 out of that. And if I play another note, now we get 9. And you saw this one over here updated that. If I play another one, 8, another 7, 6, 5, so on and so forth until it runs out of voices. And so what we do is we take this value, we plug it into MC target, which is expecting a voice number. And on the right side, you send in the message that you want to target. So we're going to do that. But actually what we want to do first is unpack this, because we only want to get the MIDI note number right now. Right now we're going to work on sending frequency values out of this in multi-channel. So let's see. Now we're just getting the MIDI note number from here, and that's actually what we're going to want to be targeting. So if we do that, now let's see what that sends out. It's going to send out what's called a set value message. So you can see it says set value 460. If I play another note, now it says set value 362. So what this means basically is a set value message is how you specify to MC objects which channel you want to set. So I'm going to make what's called an MC sig object, and you want to specify how many channels there's going to be. So we want 10 channels because we want up to 10 voices. So that's MC sig at chance 10. And all this does is it just converts a value you send in into a signal like these. And we're going to use that signal to control the gen object in just a second. So if we do this, then sending the set value message means set value of channel 1 to the value of 62. So we're going to plug this into MC sig, and let me grab the next object we're going to need is an MTOF object. So just like we had this MTOF object, which just took in the MIDI value, we're doing the exact same thing here, except it's a little trickier because it's an MC object and it's a signal. However, I'll show you a little trick we can do with MC objects. Just like with regular signals, if you hover over them, this will show you all of the signals that are passing through it. Furthermore, it'll also tell you how many channels are on that current line, so that's a pretty useful feature as well. But here, let me zoom in. I'm going to play 3 notes here, and you should see those light up in the channel display right there. Cool. We're seeing the values 64, 60, and 67 all as signals, and those are all 3 of the values I just pressed down on the MIDI keyboard. That's sending that into the MTOF, and that is going to process all 10 of those channels at the same time. And what we're going to do is we are going to send this into our gen object here. However, our gen object right now is not multi-channel, it only has 1 channel at a time. However, we've already prepared for this, and all we're going to do is type in mc.gen, and boom. Everything stays the same, and now we get this blue line right here. The only thing is we need to specify the number of channels. Now we see 10. And if we continue to play, now we can see it's already producing 10 channels of audio. However, this multi-channel signal is being fed into a single channel signal, so what we need to do now is update everything down this chain to also be multi-channel. So just like we did with gem, we can just type mc.svf. Now that's multi-channel. And this time we don't need to specify the channel numbers because it's directly connected to one where we already have. So it's just going to automatically see how many channels there are and update automatically. So we'll change that to MC, change selector to MC. We even need to change the multiply to MC. Even the ADSR. This one we do need to specify the channels because we have nothing directly connected to it. There we go, 10. You can see that's creating signal there. And now the last thing we need to do is grab an object called MC mixdown. So if we grab an mc.mixdown, this is kind of the penultimate object for multi-channel signals, and because what it does is it's going to take a multi-channel input and mix it down back into 1 channel of audio that we can hear. So the argument for this is going to be how many channels you want to mix it down to, and we're going to say 1. So if we send that out, it's still blue, but if we hover over that, you can see now it's just 1 channel. Okay, so now that we've just replaced everything with MC, let's just get back to the point where we're still hearing audio again. Because usually when you do this, you have to reinitialize everything, and I think it's mainly this ADSR that's giving us the trouble. So let me just move these. No. Okay, so we're getting signal from there, getting signal from there. Oh, selector, that'd be it. So go to low pass. There we go. Cool, so if you see, now we are getting signal again. However, every time we play a note, it's creating 10 of the exact same signal for every channel. So there's really no difference from what we had earlier. And that's because this MC gen object, whenever it receives a value like this that isn't specified as a multi-channel signal, it just applies that to every channel that you want. And that's going to be really useful for all these other effects that we have. However, we need to go back to this MC MTOF object we made and send that into the gen object. So let's see, we just made that there. I'm actually going to send this. You remember earlier I said you can make send and receive objects. You can also do that for signals and even multi-channel signals. So I'm going to do mc.send tilde. However, you can't do the shorthand. You have to type out send and receive if you do it with signals. So we're going to send MC send. We'll say MIDI notes So that's going to send out our MIDI notes through that. And here we're going to do MC receive MIDI notes. Yeah, let me shorten that. And this is what we're going to send into the MC gen object. So I'm actually going to delete this frequency dial. We're not going to need it because all of this is going to be controlled with the MIDI controller. So we'll send that out there, do this, and we are only getting one channel, and that's because these need to be specified at chans 10. Cool, there we go. So now you can see we're getting all of those MIDI notes that we specified. So let's see, is this gonna work off the bat? No. Oh, I think it is working, but check this out. So right now we have this, we're getting the different, if I play a few MIDI note values right now, you can see those 10 channels all updated to individual values, which were determined by the voice allocator, and it is creating different notes and sending those out of the MC gen object. However, once we get down to the ADSR still hasn't been voice allocated, so every time it receives a gate signal, it just opens everything up. So that's why no matter what, you're going to hear all 10 of those at the same time. So now we need to set up the voice allocation for the ADSR, just like we did for the MC gen object. So we need to go back over here, grab another MC target. This time we want to send it those trigger values. And so the way we'll do that is, if you remember here, we're getting the MIDI note and velocity. Nine. And then this is going to send out the no off message. So if I show you this, oops, wrong one. This gives us all the no off messages, and this one's showing us the no on, although I don't know why it's only giving us 9. Oh, I think we specified 9 up here. Yeah, so this is controlling the velocity now, which is fine. We're not going to need it for this. But anyways, what we're going to do, so here we're getting the no on message, and here we're getting the no off message. But we actually want to unpack this no off, because just like this, it gives us the pitch and velocity, but we only want to deal with the velocity parameter. So what we want to do is send both of these into the MC target, because the MC target is going to receive the voice number from the note allocator, then take our inputs and send that to our target. And our target for this is going to be the ADSR, so I'm going to make another send object, and this is going to be send gate. Now it's not a multi-channel signal yet, so all we need to do is just do a regular send message like that, but we'll plug that into there. So right now it's receiving the no on message, but we also need to plug in the no off. And now we go back to our ADSR, which is right here. Oh cool, it's already getting the gate message, so let's see what we get from that. Perfect, we're getting set values 6-1, 5-1, 4-1, so on and so forth as we add voices. But we can get rid of this because this needs to go into the MC ADSR, because if you remember, the set value only sets the values for specific MC objects. So now let's hover over this and make sure. Now we should see just one of those channels being triggered at a time. And that did not happen. Okay, so something went wrong there and my ears exploded. Oh. Okay, so I see what I did wrong. I forgot to delete this other gate signal. I forgot I named these the same thing. So this one's sending the gate, But then we also have this send gate up here. And we don't want that anymore. So I'm going to delete that. And I also want to delete this because I forgot to do this earlier. So this should give us the more proper values because earlier was just receiving the note. So let's go back to our ADSR and make sure that that's working. Cool. So now it's not triggering all of them, but it's still triggering 2. So let me see what I did wrong. Okay. So I took a second to figure out what was going wrong there, and I've realized what it was is I have another max patch open with the full version of this, and that one I also sent called R gate, and I had a send gate and receive gate, and sometimes they can communicate between each other if you give them the same names. So I've just called this one gate 2 and send 2, and now we're getting just one of those triggering at a time. Okay, so now there's one last thing we need to do. If you hear right now, everything should be working. So if I play a note, you see only one of those gets triggered at a time, and if I play another, we do get the polyphony that we were seeking. However, when I let go, they all stop. So it's actually ignoring this release value right now. That's because noteallocator doesn't know when certain noise. It doesn't know which noises end when, and so what you have to do is actually send this signal back to the noteallocator object. So I'm just going to send this with an MC send, call it ADSR. My other one is not named ADSR, so this is not going to be a problem this time. And I'll go, oh cool, this is already here. I made that earlier. If we send that into the noteallocator, now, if we go back, they should contain this release. Let's see. Perfect. So now I can play a full chord. And when I let go, they all release independently. And I can even hold some down. And you can hear this top note is still going to have its independent release. And the first thing I should do is maybe make the sound a little bit nicer so it doesn't bother us. That's better. But cool, so this is what we have right now. I'm actually going to clean this up real quick, so I'm going to be right back and just do that for a second before we move on to the next part. Now, just to reiterate everything that we were doing over here, because it is a little bit confusing, is we basically grab our MIDI information as raw MIDI messages, send that into the noteallocator. Now, that is going to notice what events we receive and allocate a voice with them via this voice number. So every time we hit a new voice, we get a new voice number, and we combine that with MC target along with the signal we want to actually target, and that's going to create the message that gets sent to an MC object, because MC objects are programmed to specifically recognize a set value message so that they can set values to specific channels. And so we do that for the frequencies, we convert it back to, or for the MIDI values, we convert it back to a frequency, send it into the MC gen, and that produces the noise. Then these are all MC objects. We don't need to worry about them because they're all going to have this global control, so they just process the 10 channels all with the same frequency. And then MC ADSR, we receive the gate signal from that with this MC target. That is sent into another MC object to control the channels, and we also have to remember to send that back to the noteallocator so it knows how to handle the note off messages. And then everything is mixed down into a single channel, and we have our output. So cool, that's the bulk of it. If you're here just to see how to deal with polyphonic voices, there you go. This is how you do it. It's with noteallocators and MC targets. You can do a lot more with that too if you have more complicated MC stuff. But I think I'm probably going to end that video here. I thought this was only going to be 2 videos, but that took a little bit longer than I thought. So I'll probably split this up into a third one where I add the last few features we want to see and turn it into a nice looking GUI. So thank you guys for watching. Hopefully you found that helpful, and stick around for the third video if you want to see that. Thanks.